Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 16 to 20 of the January 2016 Algebra 1 Common Core New York Regents exam. Our goal here is to cover these problems in such a way that you are really prepared to solve similar problems on your upcoming New York Regents exam. If you have any questions about what we covered here or the math section of the Regents exam in general, just ask your question in the comment section below and we'll be glad to assist you. All right, let's take a look at question 16. It says, which function is shown in the table below? So we have a table here and we have 4 functions, and the question is which of these is shown in this table. Now, when you're solving problems involving matching a function with a table, what you want to do is you want to select at least 2 pairs, okay, of x and y coordinates. Then you're going to plug in the x coordinates into each function to see if you get the associated y coordinate. All right. You want to test all functions to see which ones satisfy both pairs. One cool strategy you might want to keep in mind is try and stay away from the first few entries. Okay. In this problem, I'm going to look at pick the third and the fourth coordinate pairs. Okay. So let me call that A and B. Coordinates A and B. So we have this is A right here, and this is B. So these are the 2 pairs I'm going to be testing these functions with to see which one is the correct answer. Now, in order to keep my work organized, when I'm testing functions, I like to use tables. So everything is nice, neat, and visual. Okay, I'm going to organize my functions on the leftmost column, and then I'm going to be testing my coordinate points on the 2 columns to the right of the leftmost column. Okay, so let me get this looking nice. All right, so let's get this organized real quick. Long enough. All right, so let's start with function number 1. So function number 1 for option 1 is the linear function f of x equals 3x. Okay, so my A is the ordered pair 0, comma 1. Okay, and the question I'm going to be asking is f of 0 equals 1? Okay, so if you have an ordered pair 0, comma 1, that basically means if you input 1 into your function, you get 1 as an output. Okay, so this is another way of writing an ordered pair. So this is a question I'm going to be asking in my first column. If the answer is yes in this column, then I'll proceed to my next ordered pair, which is 1, comma 3. And the question I'll be asking here is f of the input 1 equals 3 using the function? When it has check for both rows, for both columns will be the correct answer. Hopefully we have only 1. If we have more than 1, then we have to pick another pair to break the tie. Okay. All right, so let's start with f of x. So with f of x, our input is going to be 0. So f of 0 with the rule 3x simply means you triple your input. 3 times 0, which is what? 3 times 0 is 0. Is 0 equal to 1? 0 is not equal to 1, so that is a fail right there. Okay, so this function is not represented by this table. Let's move on to the second function. This is also a linear function. This adds 3 to the input. So let's test the first column. Is f of 0 equals 1? So let's plug in 0 into this function and see what we get. 0 plus 3 is equal to 3. 3 is not equal to 1, so this is not the table. Okay, this function does not represent the table. Okay, let's move on to the next one. Option 3. Oh, we have a cubic function, f of x equals negative x to the third. Now the question is f of 0, where f of x is negative x to the third, is it equal to 1? That's the question. Well, let's test it out and see. So we just take the opposite of 0 to the third power. The opposite of 0 to the third power is just 0. Is 0 equal to 1? 0 is not equal to 1, so we have another fail. It looks like option number 4 should be the correct answer. Okay, if option 4 is the correct answer, guess what? It will satisfy both columns. So we have to expect that to happen, or else we've made a mistake in some of our computations up here. So option 4, if the function is this exponential function 3 to the x, the question is, if I input 0 into this function, do I get 1 as my output? Well, let's see. 3 raised to the 0th power is 1. Is 1 equal to 1? Absolutely. So this is a check. So we can conclude that this is the correct answer, but to make sure, we have to test a second pair just to make sure. Okay? So the question we're going to be asking in our second column is f of 1, if I input 1 into this function, do I get an output of 3? So f of 1 is 3 to the first power. 3 to the first power is 3. 3 is equal to 3. We have a winner. We can clearly see that our answer for number 16 is option number 4. Okay, let's take a look at 17. It says, given the functions h of x equals 1/2 x plus 3 and g of x equals the absolute value of x, which value of x makes h of x equal to j of x? Now, one tip you want to keep in mind when solving equations involving absolute value quantities is that you can replace the absolute value bars with plus or minus parentheses, okay? There are two ways you can solve this problem. I'm going to show you both methods. Method 1 is basically solving the equation algebraically for x. So method 1, solve for x. Okay, I'll show you both ways of doing it, and then whichever method you feel more comfortable with, you can employ it when you're taking your test. All right, so we're going to solve. We're going to set these two equations equal to each other. Since h of x is equal to g of x, now what can I replace these absolute value bars with? As indicated in our tip, the absolute value bars can be replaced with plus or minus x. Plus or minus, okay? Now this plus or minus requires us to split the equation into two, okay? So we're going to split it. The first equation will be 1/2 x plus 3 equals negative x, so that's the minus piece, and then the other one will be 1/2 x plus 3 equals positive x. All right, so when we solve these two equations, one of the answers should match the options that we have up here. Now let's solve the negative one first. So to solve this, I'll have to get x to the right side. So I subtract 1/2 x from both sides. So we have 3. Now what is negative x minus 1/2 x? Let's do that on the side here. Negative x minus 1/2 x. Imagine there is a 1/1 here. So you find the LCD, you multiply this by 2 top and bottom. Okay, so what you have is negative 2 over 2x minus 1/2x. And that gives you negative 3 over 2x. Okay, so here we have 3 equals negative 3 over 2x. Now to get x by itself, we will multiply both sides by the reciprocal of the coefficient of x. Okay, so let's go ahead and do that. We multiply by negative 2 over 3 on both sides. Why are we doing that? Well, check this out. Minus and minus, slash and dash, and then 2 divides 2 once, 3 divides 3 once, and you're left with x. And then on the right side here, the 3's also divide out. 3 goes here, 1, 3 goes here, 1. And you have the first answer, x equals what? X equals negative 2. Okay, let's look at the options. Negative 2, we can clearly see that our answer is option number 1. X equals negative 2. If you wanted to solve this equation right here, what you do for the second equation is you subtract 1/2 x from both sides. You don't have to do this because we already have an answer. I'm just showing you. And I have 3 is equal to, you have a 1/1. minus that, you have 1/2 x, and then you times both sides by 2, times this by 2 to get rid of that 1/2, and then you end up with x equals 6 as your second answer. Okay, so this, what we just did right here, this is the positive solution, and then this is the negative solution over there. All right, so this is one way of doing it, method 1. Now let me show you another way of doing this, okay? So for method 2, we're going to substitute, plug and chug, okay? So for method 2, you just plug in the answers into the equation and see which one results in a true statement. Okay, so we have 1/2 x plus 3 equals absolute value of x. We test the first option where x is equal to -2. We already know that this is the answer, so this one should work, hopefully. Let me move this out of the way a little bit. So this is equal to absolute value of x. Okay, so now we'll just plug it in and see if it generates a true statement. The closer the correct answer is to the first option, the more effective this method 2 is, which is substitution. Okay, so here we have x equals -2. That's the first option that I want to try out. And let's see if we get a true statement, okay? So the question is 1/2, replace the x with -2, plus 3, is it equal to the absolute value of -2? Is this a true or false statement? Put a question mark here, we don't know. So these 2 and these 2 divide out, 2 goes here, 1, 2 goes here, 1. So you have -1 plus 3. Is it equal to the absolute value of -2, which is 2? -3 plus 1 is +2. Is +2 equal to +2? Absolutely. So this shows that option 1 is the correct answer. So whichever method you like, go ahead and use that for your Regents exam. Okay. Okay, let's take a look at number 18. It says, which recursively defined function represents the sequence 3, 7, 15, 31? One thing you want to note is that for a recursively defined function, the input x represents the position or order of the term in the sequence. For example, if you have f of 3, the 3 represents the third position, okay, or the third term, and f of 3 represents the value of the term in the third position, okay? All right, so we have 4 values here, but if we use 3 values, well, and then another thing to note is that the first value is 3 in all the options. The first value is already 3. So we can just pick 2 more values to test like we did in problem 16. And then we want to see which of these recursive definitions generate the next 2 terms. Okay, now since I'm testing functions again, guess what? I'm going to be making use of my tables. Okay, I like to use tables to keep everything nice and organized. All right, now on the first row, I'm going to be placing my recursive definitions. I'll put the function to the left and the terms to the right. So we have the first option, option number 1. We have f of n plus 1. The next term is equal to 2 raised to the f of n is the term before plus 3. Okay, so that's the term that generates subsequent terms of the sequence. Okay, so that's option 1. I'm going to test option 1 out. Now to test option 1 out, we're going to put the terms of the sequence. So the first term that I have is, what's the first term I have? 3. Okay, so in this sequence, this is first, second, third, fourth. So F1 represents the value of the first term. So is the value of the first term 3? That's the question we're going to be asking. Okay. All right, so that's the first term. Now what's the second term? The second term of our sequence is 7. So the question is f of 2 equals 7 when we make use of the first term and the formula. Okay, are we going to get 7? Now, if it satisfies that, what are we going to do? We're going to move to the next term. Let's leave some space here for our calculations. We're going to ask, is f of 3 equal the third term? What is the third term here? 15. Okay, using the same recursive formula. So that's the question we're going to be asking. Now, let's go ahead and get started. If you look at the first option, f1 is 3, so put a 3 here. That's an automatic check. All right, now the second term. If I use this formula for the second term, do I get 7? That's the question. So f of 2 is going to be, using this formula, 2 raised to the f of n, or 2 raised to the previous term, which is 3, plus 3. Is this equals 7? 2 to the third is 8 plus 3 equals 11. Is that equals 7? No, this is not equal 7, so this is not the correct answer. We eliminate option 1. Progress to option 2. Option 2, we have the formula f of n plus 1 equals 2 raised to the previous term minus 1. Okay, what is f of 1 here in this table right here? Forgot to write a complete statement. That's not good. Okay, so is f of 1 3? Yes, it's given, clearly stated here. That's a check. Now, f of 2, if I use this formula to generate the second term, do I get 7? That's the question. So 2 raised to the term before, which is 3, minus 1. What do we get? 2 to the third minus 1 is, 2 to the third is 8. 8 minus 1, 7. Oh, this works. So what do we do? Let's test the next one, okay? f3, the third term. So f of 3, using the same rule, is 2 raised to the previous term. The previous term is 7, minus 1. Do we get 15? 2 to the 7th power is 128. You can do that with your calculator. Minus 1 is 127. Uh-oh, that is not equal to 15. So this right here is a no. This is a fail. Eliminate option 2 since the formula could not generate the correct third term. Proceeding to option 3, let's test this function right here, f of n plus 1, with the formula double the previous term, double f of n plus 1. Okay, f of 1, is it equal to 3? Well, that's what is stated here, so we have a check. Now, f of 2, what is f of 2? You double the previous term, which is 3, and you add 1. That's what the formula tells us to do. All right, so if we double 3 and add 1, we have 6 plus 1, which is 7. Voila, this one works. Does that mean this is the answer? No, let's try the next one. So we have f of 3. If we plug it in, we have double the previous term, 2 times 7, add 1. Do I get 15? 2 times 7 is 14 plus 1, 15. Oh, excellent. This one works for all 3 terms. Now let's try the fourth term, okay? Or we could just generate we could plug this in here to generate the fourth term to see if it's 31. And if that's the answer, then that should be that. So I think that should be fast. So let's try that out. So if I want to generate the fourth term, I don't have any more space in my table. F of 4 is going to be, you double the previous term, you double 15, and add 1, what do you get? 30 plus 1. Oh, excellent. This one actually works. First term, 3, 7, 15, 31. That's what we have here. So the correct answer is option number 3. Okay? The reason why I went all the way is because this one could actually fail in the fourth column. Okay? And I still have another candidate here that I haven't tested. So I went ahead to test all the values for 3, and they all worked. So I know my answer is option number 3. Okay, let's take a look at problem 19. It says the range of the function defined as y equals 5 to the x is, now what on earth is the range of a function? Well, remember the range of a function is the vertical span of the graph when it's projected on the y-axis. How low can you go and how high can you go? Okay, the acceptable outputs are forms your range. Okay, now do you remember what the exponential function looks like? All the functions in the exponential family look alike. Okay, so let me show it to you real quick. Just press Y, 5 caret x is 5 to the x power, enter, graph. Okay, so that's a general pattern of the exponential family. Okay, so let me sketch it for you, and then we're going to determine what the range is. Okay, remember the horizontal span is your domain, and the vertical span is your range. Now, the thing about the exponential function is that it gets infinitely close to the x-axis, but it never touches it. Okay, so it goes like this, bam, and up forever. So if I project this graph onto the y-axis, that's my range. Okay, so how do I do that? Well, I could take a flashlight from the left side and a flashlight from the right side. So what shadow does the graph cast on the y-axis? So if I flash my flashlight here, I have a projection right here. Bam, going down. Okay, but since it never touches the the x-axis, I can represent that as an open circle, okay? So the projection goes right here. That's the shadow of the graph projected on the y-axis. Now, if I project from this direction, so this is this projection, if I project from this direction, can you see what the shadow looks like? Let me extend my y-axis so you can clearly see what's going on here. So we're casting a shadow of the graph on the y-axis to get an idea as to what the range is going to look like. So if I flash my flashlight right here, this gets projected right here. And it's going to be going up forever since this line goes up forever. So everything from here down. So can you write down an inequality to represent this line I just graphed on the y-axis? Remember, this is your y-axis. This inequality is the set of all real numbers that are bigger than 0 on the y-axis. So we have y is greater than 0. Okay? So your answer is option number 2. All right, let's take a look at number 20, the last problem in this review installment. It says the graph of y equals f of x is shown below, as you can see here. Question is, what is the graph of y equals f of x plus 1 minus 2? This is a transformation on the original function, okay? These are pure shifts. There are no dilations going on here. So one thing I want to recall concerning translations in transformation is that when you have f of x, the function plus k, that's a shift k units up. F of x minus k is a shift k units down, as it is in this problem. F of x plus h, you gotta be careful here. You shift left k units. So when the number is grouped with the variable, you do the opposite basically. And when you have x minus h, you shift to the right. So you want to be careful. In this problem, what we will do is we'll look at the shifts that this function is indicating we do. We pick a point on this graph and then we'll apply the shift to that one point. Okay? You want to pick a point that's on a lattice point in this coordinate system so everything looks cool. Now let's look at this. We have x plus 1. F of x plus 1 basically means you shift 1 unit. Don't let this plus deceive you. If it's grouped with the x, you do the opposite, to the left. 1 unit to the left. Now, we also have f of x, we have plus 2. I'm sorry, minus 2. We have minus 2. All right, plus again. What does that minus 2 mean? This minus 2 affects the y, okay? Is it grouped with the y? No. So what does that mean? You don't have to do the opposite. You follow the direction of the number exactly as it is. So in this case, you shift 2 units downwards. All right? So we have 1, 2, 3, 4 points here. I'm going to pick this point. Let's call it point B. and I'm going to apply this transformation on B, okay, and see which one matches the resulting coordinate. So B is -1, 2. Okay, now the shifts are as follows. I'm going to shift 1 unit to the left and 2 units down. So let's go ahead and do that. So 1 unit to the left basically means that I'm going to be subtracting 1 from my x coordinate, and then 2 units down means I'll be subtracting 2 from my y coordinate. Okay, so if you do the calculations, you end up with -2, 0. So that's the transformed coordinate. Okay. Okay, so the question is, we have the b primes for the options right here, b prime, b prime, b prime, b prime. Which one is on -2, 0? Bam, option number 1 is your correct answer. Okay, so just shifting 1 point is sufficient to determine the correct answer in this problem, because all you're doing is just shifting the graph horizontally and vertically. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial to you, to give us a thumbs up. Your positive feedback is really valuable to us. As indicated earlier, if you have any questions about this video, just place your questions in the comment section below and we'll be glad to address it at our earliest convenience. Don't forget to subscribe for updates to the remainder of this review series. And you can also visit math.serve.com for more clips to help you get ready for your Regents exam. Thanks again for watching and have a wonderful day.